Okay, I'm making this video, third attempt, in order to teach people how to do Redox. This video might lead to people getting, doing better on the midterm for chem, and it might screw up people's curves and put me at a disadvantage, but whatever. You get to see how Redox works. So we're just gonna blast through this. Ready? You have MnO4 1 minus plus ASO2 3 minus yields Mn2 plus ASO4 3 minus, and your reactants are being done in an acidic solution or an acid, whatever you want to call it. So this is your equation, and this is what it looks like. If you tried to balance it regularly, it would not work. You end up saying to yourself, okay, this is probably redox, let's do some redox. So first step in redox, acknowledge that you have oxygens. Oxygens give you a 2 minus charge. So just 2 minus 2 minus 2 minus everywhere where there's oxygen. And note that you have many oxygens, not just one oxygen. So in the case of permanganate, MnO4 1 minus, that's permanganate. You have 4 oxygens. 4 times 2 minus equals 8 minus. You do the same process with the others. Note that we're not even touching the Mn2 plus on the product side. It has no oxygens, so we'll just leave that alone. Note that the overall charges are also there. MnO4 1 minus, that has an overall charge of 1 minus. So you acknowledge that, and then you say to yourself, okay, well, because of the oxygens you have an 8 minus, and you know that the overall charge is 1 minus, so do some algebra. That means that the manganese in the permanganate has to have a 7 plus charge. Do the same with the others. You acknowledge their overall charge if they have overall charges, otherwise they're 0, and then you just figure out what the other atoms have as charges. So the AS has a 3 plus on the reactant side, and the AS on the product side, I think that says 5 plus. Can't tell. I'm gonna hope I'm right. So just draw your arrows. We like those arrows. And then you have your acronym oil rig. Oxidation is losing electrons, reduction is gaining electrons. So we apply this acronym to the arrows or to the labels to see which is being oxidized, which is being reduced. Of course, in our Mn, for example, the manganese in permanganate has a 7 plus charge, and it's going to a 2 plus charge. It is being reduced because reduction is gaining electrons, and when you gain electrons you get more negative. So 7 plus turning into a 2 plus, you're getting more negative. You're getting 5 electrons. That's a 5 electron difference. Do the same with the others, or with the other oxidation. It's the same process, 3 plus, 5 plus, so it's being oxidized. Okay, now we're just going to break down that whole formula that we just worked with. Formula? No, it's not called a formula, it's an equation. I'm sorry, my bad. Into 2 other equations. Half reactions, I think they're called half reactions. I'm not sure. It's been a long time. So reduction, we're just going to work with reduction. You can work with the oxidation part of the equation first if you want to. There's no preference. I'm just doing it like this. MnO4 1 minus, leave a little space, put the arrow down, and then Mn2 plus. We left the space there because we're going to be putting things there in that space. Now, remember when I said why it's being reduced, or why why I classify the manganese on the reactant side versus the manganese on the product side, why I classify that as a reduction, and that's because it's losing 5 electrons. No, I'm sorry, it's gaining 5 electrons, it's getting more negative, it's being reduced. So basically, permanganate gains 5 electrons, that's why you have the 7 plus versus the 2 plus, that's why you have the 5 electron difference. So that's how you make up for the imbalance in the reduction equation. Now, we're talking about balancing everything out. So, you're done with your Mn, you're done with your electrons, but wait, you're not done with one thing, and what's that? You have oxygens on the reactant side. So how do we deal with that? You put more H2Os on the product side. You have 4 oxygens on the reactant side, which means you have 4 H2Os on the product side. How does this make sense? It's because 4 H2Os has 4 oxygens, so that's how you can see it as balanced. But then you're not done there yet, because 4 H2s means that you need hydrogens on the reactant side, and that's what you do. You have H plus, you have the H plus ions on the reactant side. So you have, because you have 4 H2s, 4 times 2 equals 8, that's why you have 4 H plus. Now you do your oxidation. You have these two, leave a little space between the arrow, do what you need. 2 electrons on the product side, and it's because it's being oxidized, which means that it is, if it's going from 3 plus to 5 plus, it's losing electrons, and that's why you're going to have 2 electrons on the product side. And you put your H2Os in, and your 2 H pluses on the product side to balance everything out. Yes. Next step. Nope. Yes. Yes. No. Yes. I'm sorry. I'm sorry. Okay, I remember. Basically, final reaction, you don't want any electrons. Basically, we're gonna be canceling things out. And then if you're any familiar with Hess's law, which is in the gas chapter in our textbook, you'll notice that we need to cancel a few things out. And in order to do that, well, we're focusing on the electrons. You need to cancel the electrons out. We don't want any electrons in the final product, or the final equation, I'm sorry. So we're going to be canceling them out evenly. Notice how we have 5 electrons in the reduction and 2 electrons in the oxidation. And notice one's on the reactant side, and okay, 5 electrons are on the reactant side, 2 electrons are on the product side. They are going to cancel. It is just our job to make it so that they cancel completely. So what you do is, you have 5 electrons versus 2 electrons. Elementary school or middle school? Middle school. We learned least common multiples, so 5, 2, least common multiple is 10. So that's what we're going to be multiplying with. We are just going to multiply them so that they all become 10. Or those two, the 5 electrons and the 2 electrons become 10 electrons. Which is why we multiply the 5 electrons with 2 and 2 electrons with 5, but we're not done there yet. So when we do that, we also have to multiply our the other molecules. You multiply the permanganate with 2, you multiply the electrons with 2, you multiply the hydrogens with 2. Everything is multiplied with 2 and the reduction, and everything's multiplied by 5 in the oxidation, which is why you have that. Now what are we going to do? We're going to cancel out the electrons like we want to. So those get canceled out. The hydrogens get canceled out. But we have 6 remaining on the reactant side. And the H2Os get canceled out. We have 3 remaining on the product side. It's okay, we're just going to be bringing the remaining ones down. So you didn't eliminate like the 2 MnO4 1 minus, you didn't eliminate that, you're still bringing that down. So let's bring that down. You're bringing down 2 MnO4, 1 minus plus ASO3, 3 minus plus 6H plus, yields that. I'm not going to say all that. So this is how we're going to be checking our work. The overall charge of permanganate is 1 minus. You have a 2 in front of that 1 minus, or a 2 in front of the permanganate that has a 1 minus charge overall. So 2 times 1 minus equals 2 minus, and then you do the same thing with everything else. In our arsenite, 5 times 3 minus equals, well, I hope that's a 3 minus. Is that a 3 minus? Yes, arsenite is a 3 minus. So I'm sorry, I have not been reviewing my polyatomic ions. I am really fuzzy on this. That gets you 15, and then you do the process with everything else. And this is how we're going to be checking everything. You add up your reactants, or the charges on the reactant side, and it gives you 2 minus, 15 minus, 6 plus. You add those up, it gives you 11 minus, and then you do the same thing on the product side, and that gives you 11 minus on the product side. So 11 minus on the reactant side, 11 minus on the product side. Everything works out. We're good, because they match. Now, what we just did, we just balanced our equation like we wanted to, assuming it was reacted, the reactants were reacted in an acidic solution. But what if we reacted everything in a basic solution? So you would have a different method, but don't worry, the method's pretty short. Basically what we're going to be doing is we're going to be taking the equation that we just made, the balanced equation that we just made, and then we're just going to be editing it a bit. So we bring the balanced equation down, and you have that, and instead of H plus, you're going to put the OH minuses on both sides. And this is because in a basic solution you're going to have OH minus instead of H plus, because H plus is for acidic solutions. So you have your OH minuses. Note that you have to cancel out your H pluses with OH minuses. So you have 6 H pluses, you cancel them out with 6 OH minuses. And like algebra, when you add 6 OH minuses to one side, you do the same thing with the other side. Now 6 H plus and 6 OH minuses turns into 6 H2Os. And now we eliminate again. Yes, we do. You have 3 H2Os on the reactant side, and you have 6 OH minuses on the product side. And this is our final equation, or our balance equation, if the reactants were reacted in a basic solution. 2 MnO4 1 minus plus 5 ASO3 3 minus plus 3 H2O yields 2 Mn2 plus 5 ASO4 3 minus plus 6 OH minuses. I didn't write that. Wait, no. See, I forgot to put the minus sign next to the OH, but same thing. Now, please note that I just went over the basics of Redox. Sometimes you have special circumstances that you have to multiply something with something else. I'm not trying to scare people, but just in case, you should just go through that textbook, and you'll see what happens on our midterm, just in case. But that's pretty much it. This is David Sue. You just did Redox with me. Have fun.